Hi everybody, I hope you're doing well. I'm still home with all my COVID cooties, but I should be back on Monday. Right now, I'm thinking we will still take a quiz on Wednesday of next week, and it will cover what we're working on, what we worked on last couple classes, and what we're going to work on today. We'll have time on Monday to review. We'll put it all together, do a little quizzy quiz on Wednesday, and we'll be good. Okay, so inverses, inverse sine, inverse cosines. Remembering we have restrictions. If we make a little list here, remember for my inverse sine function, quadrants 1 and 4 is where we're looking. My angle answers come back between negative pi over 2 and pi over 2. And inverse tangent, fun enough, works the exact same way. So inverse sine and inverse tangent work in a very similar fashion. Inverse cosine is the one that's a little different. Inverse cosine, we look at quadrants 1 and 2 to get our answers. Our angle answers are between 0 and pi. We need to use our unit circle to help us do these. If we're working non-calculator, then that's pretty much our main tool. Is we're sort of focused on answering these questions around the unit circle. So knowing how the sines and cosines and tangents work for the different families. And I never can remember how I've written this chart. I always get myself confused if I go down or across. I'll just do it this way this time. So sine, cosines, tangents, pi over 6, pi over 4, pi over 3. If we want the table version, 1/2, square root of 2 over 2, square root of 3 over 2. Three, 1, square root of 3. Okay. That doesn't really help us do our quadrantals. Oops, I was going to throw another page in there. So this is one tool we can use. Make that a little neater. One tool we can use to help us if we have kind of this table available to us in our head, or something we can pull out and write down on a piece of paper really quickly. Remember, I talked to you about practicing that. Another option, the part of a unit circle, okay, do your quadrantals. And then pi over 6, pi over 4, pi over 3, pi over 6 starts with the biggest x. And then the smallest x. And remember, our order pairs are cosine sine. Okay. This can help us. Jotting this down on a piece of paper in front of you as you're practicing creating this over and over again, so that when you do take a quiz, you can, if I tell you clear your desk and then I give you a blank piece of paper, you can just dump this out of your memory right on your paper and use it. Okay. So using all of those tools, we would go through these 4 questions. And if you haven't done them yet, you should stop and go ahead and see if you can answer them on your own. Okay. Angle that sine is 1, that's a quadrantal. That's going to be pi over 2. The angle that cosine is root 3 over 2. Okay, my cosine being root 3 over 2 is going to be pi over 6. The angle that's cosine, or the inverse cosine of negative root 2 over 2. So that means we're going to go in the other quadrant. So the other quadrant is basically the not quadrant 1 quadrant. For inverse cosine, that means we're going to go quadrant 2. So that's going to be 3 pi over 4 because of the number. This guy going to be in the other quadrant because it's a negative. Other quadrant, sine. Let me think about this. So this is the little sine. This is negative pi over 6. Okay. Compositions. In these problems, we're going to do kind of 2 things at once. We're going to use our unit circle, and we're going to find a value. And then we're going to take that value, and based on that value and a function combo, go back to an angle. We are going to go inside out. Start on the inside. Okay. It's like eating an Oreo. When you eat an Oreo, the stuff on the inside's the good part. You eat that first. At least that's what I think. My husband dunks them. Everybody's got their own thing about how you eat an Oreo. Some people break them apart like I do and eat the inside. Some people just bite them. Some people dunk them. Everybody's got the thing. We would talk about this if we were in class together. I love Oreos. Now I'm thinking I want some. But basically, I always call these Oreo problems because I think inside out is important. Go on the inside first. So the inside of this thing, I'm going to write this again. It's the arc sine of the cosine of pi over 3. So that means I got to go to my unit circle and I got to find the cosine at pi over 3. Now, or my table, pi over 3 cosine, or pi over 3 cosine, however I want to think about it. So the arc sine of the cosine of pi over 3 is just a tricky way of me saying, hey, I want the arc sine, or the inverse sine, of a half. Find me the angle that has a sine of a half. Okay. Now we're back to an inverse problem. We're going to go quadrant 1. I'm in quadrant 1. My sine is a half. My angle, pi over 6. There are 2 levels to this question. You get to a value inside here, and then you twist that value back to an angle. And it's often going to be a completely different angle. In lots of cases, it's going to be a completely different angle than the angle you started with. So you can see, in a way, I basically have just added an extra step onto these. These problems are very similar to the 4 you did to start class with, but I just kind of made you do a little extra thinking to do the inside. Number 2, inverse tangent of the sine of pi over 2. Remember, at any point, you can pause and take your time. Pi over 2. Cosine sine, sine of pi over 2 is 1. Another way I do things like that is a lot of times I use my picture of my graph in my head. Inverse tangent of 1. Pi over 4. We'll do one more together. Arc cosine of the sine of pi over 6. All right, so arc cosine of the sine of pi over 6. So pi over 6 sine, or pi over 6 sine. And I need to know the angle that has a cosine of a half. Pi over 3. Your final answers to these questions are angles. If your inverse is on the outside, your final goal is an angle. And that's why that arc prefix is really kind of nice. It's almost an indicator of an angle, A for angle, A for arcs. That's one of the things I like really a lot about using that prefix. Okay, go ahead and pause it right now and see what you can do on 4 through 7, and then we'll talk about number 7.